Hello, everyone. Today I'm going to briefly describe what we call the definite integral. Right. So the definite integral we write as AB of f of x dx. This A represents what's called the lower limit. B is the upper limit. F of x, of course, would be our function. And dx we call the variable of integration. Right. So let's take a look at a theorem. If f is continuous, on the closed interval AB, or at most has finite discontinuities, finite meaning I can count the number of discontinuities, then AB f of x dx exists, and we say f is integrable. Okay. So I'm going to give you some properties of this integral. And then we'll do some examples. So if we have AB of f of x dx, this is the same thing as saying negative AB of f of x dx. So if I have, for whatever reason, my lower limit and upper limit are in the wrong spot, I can add a negative, and then I can flip the limits. Property 1. Property 2, if I'm integrating from the same limit, so if I'm integrating from a to a, that's always going to be 0. So we're going to see later on that we can think of integrals as areas under the curve. So if integral is our area under the curve, if I'm integrating from the same limit to the same limit, it's going to be 0. Okay? If I have a constant inside of my integral, I can remove the constant and then just take the integral. If I add or subtract, so AB of f of x plus g of x, I'll say plus or minus. It's the same thing as taking the integral of the first one plus or minus the integral of the second one. These all would need dx. Okay? And then lastly, if I'm integrating from a to c of f of x dx plus c to b of f of x dx, this is the same thing as just integrating from a to b of f of x dx. So I can break integrals into two smaller parts if that's a little bit easier. Okay. So I'm going to give you one last rule. Let's say we have a to b of x dx. So this is our important takeaway here today. So if I have some function, in this case I'm just going to call it x, but we can always take the antiderivative, and this is going to imply. I'm going to assume a is less than b. then it is equal to, we're going to say the antiderivative. So the antiderivative of this would be x squared over 2. But instead of saying plus c, I'm going to draw this line. So this line is how I evaluate. I'm saying I'm evaluating now from my limits a to b. And this is equal to saying b squared over 2 minus a squared over 2. So we plug b into our function first. We subtract it from then plugging a into the function. And this is how we find what we call a definite integral. So I'll do a quick example today. We are going to come back to it plenty, but for right now, let's just start with a straightforward example. Say f of x is equal to x on 1, 3. If we want to integrate from 1 to 3 of x dx, what we can do is we take the integral, which I said was x squared over 2. Remember, integral antiderivative, meaning the same thing here. But now I'm going to evaluate at 1 and 3. Okay. So if I'm evaluating at 1 and 3, I'm going to plug in 3 first. So I'd have 9 over 2. Subtracted it, then from plugging in the 1. 9 halves minus 1 half is 4. Let me write that a little neater. I'm just going to write 8 over 2, but we know 8 over 2 is 4. So that is going to be it for today's class. We'll come back to that and spend a lot more time on it, but I just wanted to define what a definite integral was. Have a great day, everyone.